Okay, there is 1G. So I wanted you to, that was that question that said evaluate the series, right? So you have to find the sum to 48 terms. They said 48. So guys, if we're looking at these values, A is the first term, right? Then every time you are multiplying by a 1,09 bracket, right? Because in the first one it's to the power of 1, then it's to the power of 2, then it's to the power of 3. So that is your ratio. You raise that to the power of 48. And then there's the bottom. The ratio of -1, or if you use the formula the other way around, which is now guys, it's going to be a long while until we actually get to finance, but this is going to be a finance formula as well. And then I'm going to refer back and I'm going to say, oh, this is actually a geometric series, so we can use this formula. Okay. So we will come back to this later. I think it's only a third finance. All right, were there any questions on this? Okay, where we have number 3. Oh yeah, it's not here. Earlier, not here. Sure, there are lots of people absent today. All right, any questions on 3? What, like this one here? They could ask us, yeah. So there will be a mix of them as always, and they will also in a test or exam, they will have to be something that's unseen. So something that you haven't seen before that you need to try and figure out what to do. Yeah. But you can definitely expect some more straightforward ones as well as ones kind of like the ones in the revision. On that note, before we move on, I need to give you guys a test date and an investigation date. So please just get your diaries or whatever you make notes of dates on after. You will be doing an investigation on Wednesday, the 16th of February. Remember, investigation is not statical, so I'll just like to be present in the lesson. And actually, there's this little board and just write the date on there as well. But then you are only going to be writing a test on Monday, the 7th of March. That's very far ahead. Okay. but it will cover everything that we've done up until that point. So it's going to be all the sequences and series which we finished on Friday, possibly on Monday, but we try and finish on Saturday. And then we're going to do functions after this. That will be all of this stuff. All right, yes. Okay, and those are going to assessments that you will be doing for math this term. Okay, you're not going to do another one. Oh, you're not going to do so much. Okay. I'd like to see that. Many of you didn't do this work. Well, I also didn't do the number 7 and 8. I forgot about those. But I'm not going to mark them now. So please, those of you that didn't do this work, the revision exercise, did I post the screenshot of the okay, so the revision exercise on classroom 7 and 8, right? You need to do those for tomorrow, please. And I think I'm going to have to start checking them out again because the wheels are coming off of it. So number 7 and 8 for tomorrow. Yes. Yeah, they are. So remember you write something down at the very least, you write down 3 terms of the but you can't just look at the question and say, oh, I don't know what to do, I'm not going to write now. Yeah. On a Wednesday, yeah, it's only every second Tuesday that you got to math. Extra math. Oh, do you mean the afternoon one? Yeah. Sorry, there's a lot of talking going on, so I'm a bit frazzled. So it's every, sorry, I thought you meant you have maths every Tuesday. Remember next Tuesday we also have maths today, but there is every Tuesday on Saturday. Yeah, every Tuesday. 10 plus 3 to 10 plus 3. Okay, we are doing okay, now this is kind of new, but it's actually more of like putting together 2 things that we've learned already. So sigma notation is just a new type of notation, a new type of writing that we need to find the sum. Okay, so if you see sigma notation, they are always referring to the sum. I'm just going to do usually I write down like the general form of sigma notation, but that seems to confuse people. So I'm actually going to go straight into an example so that you can see right from the start how this actually works instead of using a bunch of variables to try and explain something. Okay, so that symbol, that is just sigma symbol. Like an M line on its side. Underneath the symbol, I'm writing n equals 1, and at the top, I'm writing a 6. Next to it, I'm going to write 5 times 3 to the power of n minus 1. That is an example of something that has been written in sigma notation. Now guys, what I want you to notice is that there's an N at the bottom of the symbol, right? And then there's also an N in this formula that we've written on the side. Does this formula look familiar? What does this make you guys think of? Third formula of a geometric pattern, right? Does that look familiar? Remember, for GP, the Tn formula was AR to the N minus 1. Right? So we see that it looks like this. Okay, so this is actually exactly that formula. You can see that A is 5, the first one will be 5, the ratio is 3, and then we have our N minus 1 at the top. Okay, so guys, what this actually is saying, we're looking at the sigma symbol. There are 3 pieces of information just in this symbol, right? We have now already identified that this is the T in the general formula, all right? So you can make an arrow there if you want. Okay, so this, the thing that's written after the sigma symbol, is the general formula for the number pattern that we're going to be working with now. Okay, so they will give you the general formula in the sigma notation. But here, in the actual symbol, firstly, the symbol means sum. So they want us to find the sum. All right, that's important. Whenever you see that symbol, you're not going to use the word sum. The symbol means sum. All right? So whenever you see that, you need to think we're going to add stuff together. Then the numbers that they write at the bottom of the sigma notation and at the top are telling us what our terms are going to be or how many terms we're going to have. All right, so they're saying that we're going to start with term 1. All right, and to get term 1, we're going to substitute n equals 1 into that formula. Okay, so that is what that means. To get term 1, we sub n equals 1 into the Tn formula. Okay, so basically at the bottom, they're giving us the value of n in the first term. Okay, get the first term, we need to sub in n equals 1. Now guys, I think this is probably what confuses people, that it's not always going to be 1. Right? They could tell us that to get our first term, n is going to be 5. All right, whatever that number is, that is the value that you substitute into this formula to get your first term. All right. Then the number at the top is the value that you will sub into this equation, this formula, up in to get your last term. Right, so at the bottom is for the first term, at the top is for the last term. All right, so this is the value of n in the last term. Now, what does n represent? Remember, n is, in this case, yes, it is a variable, but we know that n is the number of terms, right? Or the term number. So n can only be a whole number, guys. Do you remember that? We can't have like 1.5. Term 1.5. It will be term 1, 2, 3, 4, 5, 6. So we are going from n equals 1 to n equals 6. Right? The first term has an n value of 1. The last term has an n value of 6. How many terms do you think there will be altogether? We're going from 1 to 6. Okay, n equals 1. Then for the next one, we're going to sub in n equals 2. Then n equals 3, 4, 5, 6. All right? There will be 6 terms in this series. Okay, I'm just going to write that at the bottom here. For the first term, we're going to sub in n equals 1. Then for the next term, you can't sub in 1.5. All right, for the next term, you're going to sub in the next whole number. Okay, you're going to sub in n equals 2. Then 3, 4, 5, all the way to 6. We can't even where we need to stop with this number at the top. Okay, so our number of terms is going to be 6. I'm gonna write on the side from n equals 1 to n equals 6. Where that is coming from. Okay, now guys, the question is saying expand, which again is a bit ambiguous. I mean, what does that mean really? I think they just want us to write down all the terms and add it together. All right, now you can decide how you want to write down the terms. This is the first example. Let's all write it down together. Let's physically write down term 1 is equal to. Now guys, in sigma notation, they give you the general formula, the general term for this number pattern. And what is the value that we must sub in to get the first term? Whatever this value is at the bottom of the symbol. All right, so n equals 1. So for our first term, we're going to say 5 times 3 to the 1 minus 1. Please show that substitution. You don't have to do that in the text exam, but it is the first example, so let's do it properly. Yeah. So A value is your first term. Yeah, it will always be. Because they might not always use an N here, they might use a K, they might use a T here, okay, they'll use different variables. Yes, all right, so term 1, 5 times 3 to the 1 minus 1. What's 1 minus 1? 0, so this is 3 to the 0, which is 1, okay? Times 5, that is just 5, so that is term 1. You can also use your calculator for that if you want. Term 2 is going to be 5 times 3 to the 2 minus 1. So you sub in the next whole number. After the first one, you sub in the next one, which is 3. Right? So this will give you 5 times 3 to the 1. 5 times 3 is 15. Three. 5 times 3 to the 3 minus 1. 5 times 3 squared, right? What's 3 squared? 9 times 5 is 45. So guys, we could carry on, right? We could very easily do 4, 5, and 6 as well. But can we notice from this, we kind of could see from the formula already that our ratio was 3, right? But can we see that now from looking at the first 3 terms as well? We see that our A value is 5, sorry, A value is 5, term 1. And our ratio, what am I multiplying by every time? 3, okay? So you can just do a little times 3 there, and times 3 there. So that makes 5. You have your slip in there. Guys, that is actually how we're going to use sigma notation. All right, you're going to find the first 3 terms by, I'm repeating. First, you're going to start in the first number, whatever value they put here at the bottom. Remember, it might not always be 1, it can be anything. Right, whatever that number is, that is what you sub into your formula to get your first term. Then you sub in the next whole number to get term 2. Sub in the next whole number to get term 3. All right. From your first 3 terms, you can then identify. Firstly, we could see that this was a geometric series, okay, but we might not be able to see that so easily. Okay, it depends on how this is written. We'll be able to identify is it an arithmetic series or a geometric series. Okay, once you have the 3 terms, you can look at them and figure it out. Then you can see what is A, what is R. So guys, like I said, if they're saying we must find sigma, they're saying we need to find the sum. Okay, so now we're going to find the sum. How many terms do we have? From 1 to 6. Remember, we said from n equals 1 to n equals 6, we have 6 terms. We need to find the sum of those 6 terms. And what type of numbers might we have this? Arithmetic or geometric? Geometric, so then we need to use the geometric sum formula. Okay, which is that fraction 1. So remember, I'll just write it here in case you forgot it. Okay, that's what we're going to do. We're going to say 8 times r to the n. Remember that n now is 6 minus 1 over r minus 1. This is the formula that we use to find the sum, to find sigma of a geometric series. Okay, our a value is 5. The r value is 3. And then we put that again over 3 minus 1. I'm not sure what this is. I'm going to practice a whole, guys, but that is basically what we need to do. Any questions on this first one? Yes. Yes, you could have. I just want to show you a method that will work for all of them. Okay, because if they're saying from 1 to 17, then you don't want to do that. Okay, guys, so can you just ask me correctly just put down terms 4, 5, and 6 and then added them all together? Absolutely. Okay, but you can't do that in all cases. The values in the form. Oh, sorry, from the start. Yes, yeah, I was just writing the formula down. Sorry. Okay, number 2. Yeah. Okay. Let me take a picture of that quickly and made. I'm changing my mind. Question, guys. All right, now we see that the number at the bottom is not a 1. Okay, but this is still the number that we need to sub in for t into our general formula to get the first term, even though it's not a 1. Okay, it's still going to give us term 1. All right, again, we see they're saying, okay, calculate, so we need to find the value of something, but this symbol means sum. All right, so we're going to have to find the sum. Okay, your first step is going to always be to find terms 1, 2, and 3. All right, so let's do that. Term 1. And like I said, you don't have to show the substitution, but because we are still doing examples, they try to done properly. So for term 1, you're going to take this general formula, which is always the thing that's written next to the sigma notation symbol, and you're going to substitute the value at the bottom in. So for t, we're going to sub in 4. That will give us our first term. Okay, that's important. So 2 times 4 is 8, plus 7 is 15. Term 2. Now we're going to sub in the next whole number for t. What comes after 4? 5. So that gives us 17. Then we find term 3. 2 times the next whole number, which is 6, plus 7. Right, so that's 12 plus 7 is 19. Okay, what type of number type is this? Arithmetic. Okay, good. So we can see that it is an AS, and I'm saying AS series because if we're finding the sum, we're adding them together. Right? Okay, it's an AS. You are allowed to use that abbreviation in a textbook that you can write AS with an A value of 15. And what is my difference? You see that I'm adding 2 every time. Right? So A is 15 and D is 2. So now, because it's sigma, we have to find the sum. So we're going to have to use the arithmetic series sum formula. But now, guys, we need to figure out how many terms are they now going to be. I'm going from 4 to 10. Is it 6? Is it 6? Let's count. For the first one, I did 4. 5, 6, 7, 8, 9, 10. It's actually 7, right? Okay, there is a little formula for that. Here we say from 1 to 6. Now you can't actually just look at the difference between them because what is the difference between 1 and 6? It's actually 5, right? But there were 6 terms. So here the same thing applies. The difference between 4 and 10 is 6, but there are actually 7 terms. All right, now there is a formula that I want you guys to write down. Yeah. So for the number of terms, because they might give you all sorts of funny numbers here. For the number of terms, you can always take the difference between these two and then just add 1 to them. Okay, so I'm just going to write here top minus bottom. Is that fine? The number at the top minus the number at the bottom plus 1. Okay, that will always give you the number of terms. So top minus bottom plus 1. Or you can just say difference plus 1, but then you need to know the difference between 1. So in this case, I'm just going to do the calculation for this one. 10 is the number at the top, minus 4, the number at the bottom, plus 1. Right? So 7. All right, so we need to find the sum to 7 terms, and we're going to use that n over 2 formula, right? Do we remember that one? N over 2 bracket 2a plus n minus 1d. Okay, so 7 over 2, n over 2, remember? Times 2a, so 2 times 15, plus n minus 1, 7 minus 1 is 6d, which is 2. Okay, amazing. This times 7 over 2, it's 147, is what I'm getting. Does anyone else calculate it? Okay. So I want you guys to panic when you see that there's a different number here. Okay, it is going to affect your working. But remember, that is the number you sub in for your first term. Then you sub in the whole numbers after that one. And it also affects the number of terms that you're going to have. Okay, just find the difference between those two numbers and add 1. Okay, I do want to do another example with you guys where they're giving you a series and they're asking you to write it in sigma notation. Okay, so just make sure that everyone's done copying this down. Go to the page. Are there any questions on this one? Sorry. Go to number 3. Okay, now guys, if we're thinking of sigma notation, right? We have that symbol, then we need to write, and I suggest that we work with n, okay, because that's the variable that we always work with for these number patterns. So at the bottom, to make it easier for ourselves, we're going to write n equals 1, okay? Because if we're using n equals 1 for our first term, we can just use our normal term formula, okay? You'll see now. We need to figure out, is this an arithmetic sum, a series, sorry, or a geometric series? Okay, so we look at the numbers. Do we notice that I am adding 3 every time? Okay, so plus 3, plus 3, plus 3. Okay, so we notice that this is an AS with an A value of 5. Do we agree the first term is 5? And the difference is 3. Now, in that sigma notation, we need to write the general formula. Okay, it's the symbol with the n equals something and a number, and then we have the general formula next to it. Now, guys, if I ask you just to find the general formula, to find Tn of this, what would you use? It's an arithmetic one, so to find the n term n, remember we have that formula, a plus a minus 1 b. In the sigma notation, the term formula has to be written next to that symbol. Okay, so I understand why people get confused. We're doing a sum, but we're using the term formula in that notation. Okay, that's very important. So now we can just sum these values in. My a value is 5 plus a minus 1 times d, which is 3. Now we just need to simplify that. So we're going to say 5 plus 3n minus 3, right? I'm multiplying that 3 into that bracket. And then we can just simplify it to 3n, and then we have 5 minus 3, which is 2, right? So 3n plus 2. Okay, so I'm going to write that. So I'm going to write my sigma symbol. We'll talk about the numbers just now. But next to it, the general term of this number pattern is 3n plus 2. That is what we write down. Okay, so sigma notation is really kind of placing all of those formulas all together in a sense. Right, because if they're asking you to calculate it, you need to use the sum formula. If they're asking you to write it in this notation, use the term formula. Okay, so it is easy to get confused. You need to keep your work a lot easier. Now guys, if I want to get term 1, what is term 1? 5. What does my n value be here for me to get term 1? 1. Okay. I'll just go now again. Okay, so then we need to write the n value that we have to sub into this formula to get our first term. That's the number that we saw at the bottom. All right, so then I ask, what must n be here for this to be equal to 5? Now 3 times 1 plus 2 will give me 5. Now guys, if you are using this normal term in formula, right? Then your n will always be 1 for your first term. Because what is n representing here in this formula that we're using? N represents the number of the term, right? The term number. So if it's term 1, what is my n value? The n term 1, n is 1, all right? But if you are using this formula, right, all the geometric formula, your first n value will always be 1. Okay, this is how when you are writing it in sigma notation. Okay, you will never have to write a different number there, is what I'm saying. If you are taking a number pattern, you're writing it in sigma notation, it's always going to be n equals 1 at the bottom. Okay, not n equals 2 or n equals 4 or anything else. All right, they can give you a different number at the bottom. But when you are writing it in sigma notation, it will always be n equals 1 at the bottom. And then it's very easy to write the number at the top, because how many terms do we have? 9. So the number at the top is going to be 9. We're going 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 terms. So the number at the top is then going to be the number of terms. Okay, always, guys, when you are writing it in sigma notation, always do n equals 1 at the bottom, and then the number of terms at the top. Okay. When they are giving you sigma notation, they might give you different numbers, but don't try and do them. Okay, so it makes things much more complicated. All right. Are you guys ready to try some on your own? Okay, well, just try. Exercise 1.7. I'm not going to give you anything funny. I'm just going to give you questions, just like the ones that we've done now. So questions where you need to find the sum, and then questions where you need to write it in sigma notation. Okay, that's all we're doing today. We'll do other types of questions tomorrow. Sorry, some of these questions are a bit odd. So just want you to do 2A as number 2, all the others are fine. And then okay, guys, number 2A is one like the one we did now. You need to write it in sigma notation. And then number 4, the question again says evaluate. So for that, I want you to actually find the sum, actually calculate the sum like we did in the first 2 examples. Okay, so you're going to follow the exact same step. You're going to find terms 1, 2, and 3. Figure out is it an arithmetic series, geometric series, use the sum formula that goes with that, and then calculate the sum. Okay, so in number 4, there are 5 questions, but all 5 of them are these types. We're defining the sum, and then there's one where you need to write the sum. Okay, get going on that now, guys. Please remember, if you didn't do the revision exercise from yesterday, number 7 and 8, we are going to mark that tomorrow.